In the frozen wilderness of northern Russia, near the border with Norway, Soviet scientists embarked on one of the most ambitious scientific projects ever attempted. Their goal was simple in theory but monumental in practice: drill deeper into the earth than anyone had ever gone before. The project became known as the Kola Superdeep Borehole, and what began in 1970 as a demonstration of scientific and engineering excellence soon transformed into a journey that challenged some of geology's most accepted assumptions. For years, researchers expected the drill to confirm existing models of Earth's crust. Instead, every new kilometer seemed to reveal surprises that no one had predicted. By the time the borehole reached its record depth of 12,262 meters, the scientists involved had accumulated evidence suggesting that the planet beneath their feet was far more complex than textbooks claimed. The drilling operation started with confidence. Soviet engineers believed they understood the structure of the continental crust well enough to predict what materials would appear at specific depths. Early progress seemed to validate those expectations. Granite formations appeared exactly where models predicted, and the data matched decades of geological surveys. The project advanced steadily through the 1970s, passing milestones that drew attention from scientists around the world. Yet as the drill penetrated deeper layers of the crust, researchers began noticing inconsistencies. One of the first major surprises emerged around 7 kilometers below the surface. According to seismic studies, a transition from granite to basalt should have occurred at this depth. Geologists referred to this expected boundary as the Conrad discontinuity. However, when core samples arrived from the target depth, they contained nothing but more granite. The anticipated basalt layer was nowhere to be found. This unexpected result forced scientists to confront an uncomfortable possibility. Either the seismic interpretations that had guided geological understanding for decades were flawed, or Earth's crust was structured differently than previously believed. As drilling continued, more mysteries appeared. Researchers discovered water trapped deep within fractures in the rock. Conventional wisdom suggested that liquid water should not exist under such extreme pressure and temperature conditions. Yet the evidence was undeniable. The water appeared to have migrated downward over immense geological timescales, traveling through microscopic pathways before becoming trapped within the crust. This finding indicated that deep rock formations were far more permeable than scientists had assumed. The discovery carried important implications for understanding underground fluid movement, mineral formation, and even the long-term cycling of water through Earth's interior. Another puzzle emerged from the drilling fluids returning to the surface. Scientists detected unusually high concentrations of hydrogen gas mixed within the mud. The gas appeared in quantities that existing models could not adequately explain. Researchers debated whether it originated from chemical reactions occurring deep underground or whether it had remained trapped within ancient rock formations for millions of years. Whatever its source, the hydrogen challenged assumptions about the chemical environment of the deep crust. The deeper the drill traveled, the stranger the findings became. Perhaps the most remarkable discovery involved microscopic fossils found within ancient rock samples. These fossils resembled primitive marine organisms that had lived billions of years ago. Their presence at such depths astonished researchers because prevailing theories suggested that temperatures and pressures in the lower crust would destroy delicate organic structures. Yet detailed examination indicated that these ancient traces of life had survived conditions previously considered impossible. The discovery raised important questions regarding the preservation of organic material and expanded scientific discussions about the limits of life in extreme environments. While these findings generated excitement among researchers, they also created significant challenges. Many of the observations contradicted accepted geological models and decades of published research. Scientists who examined the data understood that their results would force revisions to established theories. Some researchers worried about how officials and institutions might react to discoveries that undermined long-standing assumptions. During the Soviet era, scientific prestige often carried political significance, and findings that challenged accepted doctrine were not always welcomed. As a result, some reports received limited circulation, and certain conclusions remained confined to internal discussions rather than being immediately shared with the broader scientific community. Meanwhile, the physical conditions encountered at depth created growing engineering difficulties. Scientists had predicted that temperatures near the bottom of the borehole would reach approximately 100 degrees Celsius. Instead, measurements revealed temperatures approaching 180 degrees Celsius. The unexpectedly intense heat transformed the surrounding rock. Rather than behaving like brittle stone, portions of the deep crust began to act more like soft plastic, deforming under pressure instead of fracturing cleanly. This behavior complicated drilling operations and caused repeated equipment failures. Drill strings twisted, tools became trapped, and expensive machinery was lost deep underground. In 1984, a major setback occurred when thousands of meters of drill pipe broke off and fell into the hole, forcing engineers to begin a new branch from a shallower depth. Years of work disappeared in an instant. Nevertheless, the team persisted, determined to push deeper despite mounting obstacles. By the late 1980s, the Kola Superdeep Borehole had achieved a depth unmatched by any other human-made excavation. Yet the project was approaching its practical limits. Extreme temperatures, unstable rock conditions, and escalating costs made further progress increasingly difficult. The collapse of the Soviet Union added another challenge. Economic uncertainty reduced funding for scientific programs, and support for the drilling project gradually disappeared. In 1994, operations officially ended. The ambitious goal of reaching 15,000 meters remained unfulfilled. Although the project failed to achieve its intended depth, many scientists later argued that its true success lay elsewhere. The borehole had exposed weaknesses in existing geological models and provided a wealth of new information about Earth's crust. In the years following its closure, researchers worked to analyze and publish the enormous collection of data gathered during more than 2 decades of drilling. International scientists reviewed the findings and gradually recognized their significance. Similar observations from other deep drilling projects helped confirm that many of the unexpected results were genuine rather than isolated anomalies. The absence of the predicted basalt layer, the presence of deep water, the unusual concentrations of hydrogen, the preserved fossils, and the extreme temperatures all contributed to a broader reassessment of geological assumptions. The Kola Superdeep Borehole ultimately became a symbol of both scientific ambition and scientific humility. It demonstrated that even well-established theories can be challenged by direct observation. The project reminded researchers that nature does not always conform to human expectations and that genuine discovery often begins when evidence contradicts accepted beliefs. Today, the borehole remains sealed beneath a heavy metal cap, its narrow shaft descending more than 12 kilometers into the crust. Though silent and abandoned, it continues to represent one of humanity's greatest attempts to explore the hidden world beneath the surface. The lessons learned there still influence geology, geophysics, and deep Earth research. Scientists continue studying the data and samples collected from the site, searching for new insights into the processes shaping our planet. Future drilling projects may eventually reach even greater depths, perhaps one day penetrating Earth's mantle itself. If that happens, researchers will almost certainly encounter new surprises, just as the Kola team did decades ago. The enduring legacy of the Kola Superdeep Borehole is not the record it set, but the realization that the deeper humanity looks into the Earth, the more mysteries it discovers. Every unexpected finding revealed that our understanding of the planet remains incomplete, and every contradiction opened the door to new knowledge. In that sense, the borehole succeeded beyond anyone's expectations, proving that the greatest scientific breakthroughs often emerge not when theories are confirmed, but when reality turns out to be far stranger than imagined.